Hello everyone. Welcome to the Cambridge 0606 IGCSE Additional Mathematics course. This video will cover Chapter 4, which is Equations, Inequalities, and Graphs. So let's get started. The first thing in the syllabus is actually equations related to modulus. So if you quick reminder, basically, the modulus of a constant a gives you a, same thing like this. So modulus is really just if you imagine a number line 0, then what modulus is the distance from 0 to that number. So the distance is actually going to be the same regardless, right? The distance between 0 and -2 and the distance between 0 and 2 is the exact same. So let's get started. If you have an equation of this form, modulus ax plus b is equal to c, such as this one, you can solve it by you remove the modulus by essentially taking ax plus b is equal to plus or minus c here, and then you solve that equation. So you can make two equations like this, and then you can solve them separately. This is what the graph of this equation would look like, and so as you can see here, we actually have two roots, this one and this one, where the line intersects the graph. Now another form here, so again you can do the same thing. Ax plus b is equal to plus or minus cx plus d, and then you can expand the brackets there, so as you've seen here, and two different solutions. Now one thing to note is that to when you're solving any equations, just make sure to substitute back your solution into the equation to check that it actually works, because in this case, if you actually look at the graph, you'll see that while x is equal to minus 8 by 3 seems like an algebraic answer, there's only one point of intersection over here and no other point. The gradient here, this is going away. These two are also diverging here and here. These are diverging, and then this negative part will never intersect. So just remember to check that, and then x is equal to 1 works. So that's the only solution. And the third form here, now this has modulus on either side of the equation. So what you do is you square both sides, because remember again, -2 squared is 4 and +2 squared is 4. So again, it doesn't matter if it's negative positive, similar to modulus here. That's why squaring actually works. And um, the actual definition of modulus does involve this thing here, where we say this is actually a technical definition that is considered in higher advanced mathematics. You don't need to know this, but that's actually one of the higher definitions, and that's why this method works. So again, you just do the algebra here, solve the quadratic, again substitute them back into check. But if you look at the graph here, you can see we actually do have 2 points of intersection, so that works. All right, now the quadratic one, again, same thing as before, take plus or minus d on both sides, two different equations. This one has no real solutions, and so you can just sketch this one here. Now, something that would actually have is when, so usually if you have a quadratic equation like this, the reflection of that would be like this, and so if you had a line like this, then it would have 4 points of intersection. This one, because the graph looks like this, there's only going to be 2 anywhere, or 0 if it's below the thing. Right, now moving to inequalities, actually this is the second part. So again, modulus inequalities, so just rearrange to get the modulus on one side, the constant on the other. And here, guys, actually, because of the whole multiplying and dividing by negative switches the sign, it is simpler to just square both sides and then solve the quadratic inequality, which we covered in earlier chapters where we talked about quadratic inequality specifically. Then again, same thing here, essentially. It's just the sign is reversed, so you're gonna have to view it differently. There's always graphs accompanying the thing here if you want future reference on how it actually looks like. You will probably be expected to know how to sketch these graphs, so it's simpler to just substitute the equation into your calculator. But for the non-calculated paper, uh, the vertex point is basically just sketch the graph and reflect it in the y-axis, in the x-axis. Sorry, yeah, in the x-axis, right? Now this one, modulus on both sides, but we're going to square anyway, so that doesn't make a difference. And then this one, just, and again, same thing, just keep squaring. If basically, if it's an equation, you add plus or minus. If there's mod x on both sides, then we do squaring. And then if, so this is just mod x is equal to y, you do this, my bad, wait, okay, wait, yeah, you do x squared is equal to y squared. Mod x is equal to y. We do plus or minus. Here we square. And if it's an inequality, you square. It doesn't matter. Either side could be modulus or not. You square if it's an inequality. Again, quadratic in the modulus doesn't matter. We just here you can see an example of where you'll have 4 points of intersection. Obviously, because it's inequalities, it's not equal to, we're dealing with the inequalities here. Let's say, so look at the graph for this one. It says greater than 3 here, so we can see anything this direction, which is actually going to be less than -7/2. Then you have from here to here this region, which is this one, and then you have to the right of this, which is x is greater than 0 actually. So I guess it's a bit of a the graph may not be correct because the intersection point would actually come out to be here then. But yeah, again, same thing. This one has only 2. Right. So that's the end of the inequalities part. Now, oh yeah, one thing. So in quadratics, you actually don't square. This is actually the part where you do the negative positive thing. I forgot to cover this 1 second. Yes, all right. So basically, if you have ax squared plus bx plus c greater than d, what you can do is you can just take ax squared plus bx plus c is greater than d, and ax squared plus bx plus c is less than -d. So this will give you these two. The same thing here. We less than equal to 2 makes less than equal to 2 and greater than equal to -2. Right now, this is actually what we're essentially, if you have some more complex equations, they're actually quadratics if you look at them closely. As you can see here, if we take a is equal to x to the 2 by 3, you can see that this is just a squared plus a minus 12, which is a quadratic equation. So you can find values for a. Again, we assumed this, so we can just put x to the 2/3 here, and again, this has no solutions because x squared is can't be negative, and it doesn't matter you have cube root there or not. So we have only this one. Again, same thing. Yeah, ln 5x is covered in a future chapter of logarithms, but again, you can make the quadratic and solve until a, and once you cover actually this, you can, once you cover natural logarithms, you can come back to this and actually understand how this is solved. All right, now we've got cubic graphs. So for this, you'll actually need to remember this shape. So y is equal to x cube has this shape, and y is equal to negative x cube then has this shape. These two you need to remember basically. So if the coefficient of x squared is positive, this shape, the coefficient is negative, it will be this shape. Coefficient can't be 0, otherwise that becomes a quadratic or a linear depending on the other ones. So let's see, if we have now, according to the syllabus copy, you will only be given an equation in linear factored form. So you really don't need to know that, but factoring cubic polynomials is a part of the syllabus covered in future or earlier chapters. So basically what you do is these are the roots, so you just plot them on the graph, and because this is x cube positive, it'll go up down like this, and because you'll have two turning points like this, and -1 into -3 into -8 is -24, so that's the y-intercept. It's not to scale, but you get the idea. And then modulus f of x just reflect the graph in the x-axis, right? Inequalities, same thing. Draw the graph, and well, you look at the areas where it matches the inequalities. So greater than 0 will be this area here and this part. So You got 1 to 2 and x is greater than 3. Now obviously you also have less than 0, less than equal to, greater than equal to, and that will vary by question, but the process is essentially the same. So yeah, that is the fourth chapter of Math. I hope you learned.